All right. Hearing none, so I'll go on to the last problem tonight. Okay. So here, looking at this problem, it asks us to find the values of I1 and I2. Also on the side here, I ask you to find the power in each resistor and are they absorbing or supplying. So let's take a look here. Uh, Now this problem is going to involve a trick that is can be useful. Uh, so if we were to say pure parallel current sources can be added or subtracted in specific directions. All right. So what does that mean? So if we look at this circuit, we see that this one is pointed upwards, this one's pointed downwards. What we can do is we can say uh, that we have 4 going up, we have 2 going down. So therefore, if we did 4 minus 2, it'll give us 2 amps. And what we can do is effectively remove one of the sources, because now we can't really analyze it. If we just try to attack this problem from the beginning here, we know 2 amps is going this way, but what's coming into it and what's going into that? So in order to avoid that, doing this combination removes that problem for us. Are they not flowing in the same direction? Well, so let's look at it here. If they're not flowing in the same direction, so this one is sending current this way, right? But what about this one? Is it sending it up that way, or is it just passing it up? So that's kind of the thing, is that we don't know quite by looking at this what the current is actually going to be doing. So by removing the other source, it just simplifies the problem down. But we say that pure parallel is this entire circuit needs to be in parallel. So everything needs to be the same across it. Uh, so if we go here, add 5, the 5 resistor, and then the 15 ohm resistor as well. Now what we're saying is this current will break off here and then break off there and travel through here and meet back up, where that's I1 and that's I2. Okay, and then all we had to do from here is do a quick current division. So for current division, we're going to need, we'll say I1 is equal to R equivalent over R1 times I of S. So R equivalent will be equal to 5 times 15, 5 plus 15, this will give us 3.75 ohms. So 3.75 ohms divided by, we'll say I1. So we'll go resistor 1, which was 5 ohms times 2 amps. So therefore I1 is going to be equal to 1.5 amps. Okay. And then we can do a couple things with this. We can say, we can either do this again for I2, in which case it would be 3.75 ohms over 15 ohms times 2 amps, which would give us 0.5 amps. The reason why I knew it was 0.5 because rather than doing that, if you just did a KCL on it with 2 amps going in and 1.5 amps going that way, 2 amps minus 1.5 amps will give you 0.5 amps. Sorry, it's 1.5 amps right there. So 1.5 amps will be I2. All right. Does anyone have any questions about this problem?